Before I teach you how to do net ionic equations in terms of an actual reaction, I just wanted to give you a visual of what's actually happening. I think it's easier to understand chemistry if you understand the why and you're not just trying to memorize what the teacher is doing. So let me just give you a little molecular diagram to show you what's actually happening to help you understand it better. So first of all, we're starting this reaction with AB, which is in the aqueous form, which means that it's dissolved in water. So really what it means, some people say aqueous, by the way, either one's fine. So what that really means is that we have a floating soup of A positive ions and B negative ions floating around. Same thing with C and D. Notice that you have the AQ after it, so we've got C positive and D minus floating around. So we're starting with two soups of floating ions, and we're going to mix them together. Now remember, if they both remain AQ, then they're all just floating ions the whole time, and that's when we say that it has not reacted, that a double replacement reaction does not occur if the two products remain as AQ. But let's say that AD ends up being a solid precipitate, which is a fancy word to say that it's a solid that's formed from the two solutions. So in this case, C and B are still going to be floating ions because they're still AQ. So C positive and B minus are floating around, but now AD has become a solid. And initially the solid will be little particles floating around that you can't see through. So it's going to look cloudy. That's what a precipitate looks like. If you let it sit there long enough, it'll usually sink to the bottom. And so you'll end up with this little paste down here of the solid AD that is stuck together. And so notice that our beakers look different. Our starting beakers look different from the ending beakers. And so we say that a reaction has occurred. However, not all four of these letters have changed. So notice that if I look at C over here, it's C positive floating ion, still C positive floating ion. You look at B minus, it was a floating ion over here, it's still a floating ion. So C and B are there, they're in the reaction, they're in the beaker, but they're not actually participating in the reaction. And so it's the same name that we would give to people who go to a sporting event, like a soccer game or a basketball game, who are sitting there in the bleachers, but they're not participating in the game. And we call those spectators, which is a good word because you probably already know that word. So our spectator ions for this reaction are C positive and B minus. Notice that I have the charges on them. If I'm asking you for the ions, you have to put those charges because really that's what they are in the solution. If you write it together, like down here where we have CB written together as AQ, you don't have to write the charges because they cancel each other out. But if you're listing them as separate things, then you need to go ahead and have the charges on them. And so what we can do is now take them out of the reaction. So if you have a part-time job, you probably get a paycheck where you have your gross pay, which is what you earned. So if you're a lifeguard and you saved lives, then you get paid. But then taxes come out to pay for things like your public education that you're receiving right now. And what you're left with is called your net pay. So net is what you're left with after some things have been taken out. And so what we're going to do now is take out the things in this reaction that didn't actually matter, so the C and the B, the C positive and B minus, because they didn't actually participate in the reaction. And then what we're left with is going to be A positive. If you're not writing it with B, then you have to put that charge on it. D minus, and then those are going to react to form the AD solid. And this is called the net ionic equation. Net because we've taken out the spectator ions, ionic because notice that you have ions that are coming together to make a solid, and it's just part of the reaction. So that's just kind of the general idea of what's going on. Now let's go ahead and talk through it. There are a few rules. Anything that's AQ can be split into their ions. Don't forget that when you break it apart, you have to put the charges on it. Strong acids, we haven't really talked about yet, but we will eventually. Strong acids can be broken into ions, but if it's a solid, liquid, or gas, then it can't be separated. And the only liquid that you'll ever see for this is going to be H2O. And the main thing you'll focus on are the solids that you figure out from the solubility rules. And then this is a vocab word. Make sure you understand that spectator ions are the things that stay ions the whole time, so they can be removed. And then what we're left with is called the net ionic equation. So a little bit of new vocab there. Let's go through one of these examples so you can see how to do it. So first of all, we're going to write this is the entire reaction written out. Now notice that they already told us what was aqueous and what was solid. They don't have to do that. So if they just wrote the reaction, or if you have to predict the products, you would have to use those solubility rules to determine which of the products are aqueous, meaning soluble, or which of them are solids, which means they're insoluble. But in this case, they already told us what that was. So for the net ionic equation, we know that the solid is important because it changed. It was not a solid on the left, and now it's a solid on the right. And then on the left, we can break that apart into ions. So we started with a barium, it's actually 2+ if you look it up, and we had a sulfate 2-. So in AP chemistry, we get into much more complicated ones where you have different types of reactions, and the net ionic equations will look much different. But for this class, we're going to focus on double replacement. And so you're going to end up with a compound that's a solid on the right, and it'll be formed from the ions on the left. Now, it won't always be a 1-to-1 ratio. So notice this is +2 -2, so they cancel out. But if it was not, you would have some coefficients there to balance the reaction. And we'll do one like that in the progress check. And then your spectators are the things that are not in this net ionic equation. So if you look back at your reaction, it's actually going to be the things that are in the aqueous compound because it stayed aqueous the whole time. So our spectator ions, we're just listing them, are Na+ and Cl-. And notice that they have charges. So when you're doing these kinds of net ionic equation problems, notice that everything has a charge except for that solid. The 2 ions on the left in the green reaction have charges, and the 2 ions in the blue list of the spectator ions have charges as well. So the biggest mistake I see people make is they split apart compounds and they forget to put those charges on them. And the very last thing for this chapter is that there are several lab tests in the curriculum that you need to just be familiar with. In a normal semester, we would do some of these labs so you could actually see this happen. Obviously, we can't do labs right now with remote learning, but you can still understand what they're trying to test for. So a burning splint is when you light a splint on fire. If you stick it into a test tube that contains hydrogen, so let's say that you do a reaction and you capture the gas in a test tube, you can put the burning splint in there and you'll hear a pop sound that indicates that there's hydrogen present. If you blow out the splint and quickly put it into the test tube and it reignites, that usually means that oxygen is in the test tube, and carbon dioxide will smother the flame. In fact, a lot of fire extinguishers have carbon dioxide in them because it's a very heavy gas and it will smother the oxygen so that the reaction can't continue. So if the fire goes out, that means carbon dioxide is in there. And the very last one is, this is also listed in the curriculum, if you have clear colorless lime water and you add CO2, it's going to turn cloudy. And that is it for this chapter. Good luck on the progress check.